Alright, so we are looking at a particles in motion. This is a horizontal line movement. S of t is the function's position. And t is greater than or equal to 0. It's given by that. As far as a default, there's no negative time. And immediately you see that it's in meters per second if it's a velocity. So you have meters and you have seconds. So you're given the position function. The reason why I'm recording this is because I want you not only to know the answers, but also to look at how fast can you do this with a calculator and what's the most efficient way in order to get to those answer pieces. Alright, so people who are practiced with the calculator, this is again why I'm recording it. You will be able to finish. If you don't necessarily practice, it's going to be difficult for you to finish this problem on the test. Alright, so let's go ahead and go over here to the calculator first. And what I wanted to do is I want to store this function with you very quickly. Okay? So let me show you how I started this off. Alright, so at the very top you'll see what I did was I just typed in the function and I stored it. Okay? So typing in the function with me, I'll copy it at the very bottom, just store it as s of t. Don't store it as s by itself. It has to be variegated with an input so that you have that t value there, and you press enter and it'll say done. Okay? And you know you're going to need the velocity function, you know you're going to need the acceleration function, and yes, you could do that by hand, but you're going to have the calculator very extensively on this test. Why not use the calculator to your advantage? Okay? So the first one says, what is the velocity function first? So what you could do is you can press this button right here next to 9, and you can say, what is the derivative in respect to t of the function that I have stored that's called s of t? So there's the first part to your answer. It's negative 3t squared plus 14t minus 14. This is s prime. The second one says at 2 seconds, okay? So if I want to know at 2 seconds, what I can do is press follow menu, 4 for calculus, 2 for derivative at a point. You're saying at a specific point in time. What do you think I put here? T. What do you think I put for the value? 2. And is it the first or second derivative from what I have stored? It's the first because we're looking at the velocity. Now notice the notation. You're saying not only take the derivative of said s of t stored function, but I want you to plug in 2 all the while at the same time. So the answer becomes 2 meters per second. Okay? And then we'll go over points in just a bit, okay? Yeah.
Where do you go to do that little shortcut? Yeah, where did
This one right now
Yeah.
that I just did, menu 4-2.
Menu 4-2.
It's a derivative at a point. So menu 4 for calculus. We're going to do it again. Watch. So menu 4 for calculus, 2 for a derivative at a point. And I'm going to do the same thing only for part C, which is an acceleration piece. So I'll put t as my input variable. I'll put 2 because it's at 2 seconds. And this time I'm going to do the second derivative from what I have stored. So this will put the second derivative for whatever I put in this parentheses. And what do I have stored? The position, velocity, or acceleration? Position. So I'll just say, what's the second derivative of this? Why do I keep doing that? S of t, and then put 2 in, and then give me the answer. And you get 2 meters per second squared. Okay? And then furthermore, on these questions, you have part D. It says, find the displacement of the particle during the first 2 seconds. Guys, displacement is just change in position. So if I'm looking at 2 seconds and 0 seconds, it's going to be s of 2 minus s of 0, and you get your full displacement is negative 8 meters. Okay. Next one says, find the total distance traveled by the particle during the first 2 seconds. Now this one's a little bit more involved. I want to know the total distance traveled. So I need to know the signs of the velocity function. Okay. Now over here, I already have it shown as far as the signs of the velocity function. Okay, so now just press up arrow. My bad. Try that again. Okay, there we go. Keep going. So, oh, not that much. My bad. Part A. There it is. 2 meters per second, you see the equation. You see that I stored the function as s of t. Scroll down. Part B, you see that it's 2 meters per second squared. And then part C, what we're talking about right now, if you could scroll down even more, I need to find what are the directions of this piece. I need to see what are the signs that I'm looking at of the velocity function. When am I traveling backward? When am I traveling forward? The way that I got this with the calculator, again, this is why I'm recording this, is that I want to find the zeros of the function. If you could say it back there. I want to find the zeros of this function. Okay? I want to find the zeros of the velocity function, not the position, but the velocity, because it will tell me when it's traveling forward or backward. So here we go. So it'll be menu 3-1 to solve, and I'm going to find when the derivative of my stored function is equal to 0. Okay, so pressing this button right next to 9, I'm going to do the first derivative. It's in respect to t. What do I put here? S of t. And then I got to be careful and kick out just one parentheses, set it equal to 0, because you're saying when is the derivative of s of t equal to 0, and we'll put comma what? T. So now it'll give you these weird numbers. What I want you to do is I want you to press Control T to give me the decimals. Now, as we work through a problem, how many decimal places do I want you to round to? As we work through the problem, 6. If you only give an answer for each piece, the answers can be to 3. But as you work through the problem, I want you to work 6 decimals. Okay, otherwise you'll be too much off of the AP exam. Now, with this being said, I could just press up and press enter, and it will display more decimals. So right now, I would write down on my paper 1.451416 and 3.215250. Those are the numbers that I'm working with per se as I go through these answers. Now, for part C, you notice that I wrote at 1.451 and 3.215 because that's the answer as far as just to that piece. So I'm going to say that it's at rest at time 1.451 and 3.215 seconds because the derivative is equal to 0. Okay? It will move to the right on this interval between 1.451 seconds and 3.215 seconds because the derivative is positive. These are particles in motion. It will move to the left because s prime of t is negative on 0 to 1.451 and then 3.215 all the way to infinity. Notice that I have the particle in motion when I start the timer. It's already in motion, that's why I have the bracket there. Everything else, it's in between. And notice again that I'm putting 3 decimal places. So let's go back to the question that says, for D, find the displacement of the particle within 2 seconds, the first 2 seconds that is. So you see what I did here is I just, if you can scroll down please. D, I'm going to put the final position minus the initial position. So it's s of 2 minus s of 0, which gives me the negative 8 meters. That's it. Keep going if you can, please. Now, real quick. E asks for something different. E on the question is asking, find the total distance traveled during the first 2 seconds. That means when I go back over here to this graph, I need to see from 0, whoops, maybe not. From 0 to 1.451, it's going to be negative. From 1.451 to 2, it's going to be a positive. Now with the calculator, you can see when these are positive, negatives, and so on and so forth. And I kind of skipped over that just a little bit that I'm going to show you right now. Okay, here we go. I know that the zeros of my function up top were at 1.451 and that 3 point whatever. Okay, the way that I can find out the sign changes in between the interval, real quick, Grant, can you scroll up? Right there. So the way that I can find these signs with the calculator very quickly are the following. Watch. I just want to know the sign. I want to know if it's positive or negative. So I could say menu 42 at t, and a little bit before that first y-intercept, and remember that first y-intercept is 1.451. What number could I use to the left of that? 1. And then I'll just press S of t, and I basically, all I care is that it's negative. So that's why I put a negative right here for this first interval. The second one, I can test something between 1.4 and 3.2. Any number, what could I do? I could do 3. So I'm going to go over here, watch this, just scroll up and copy by pressing enter, and then just put 3. It's a positive. That's why I have a positive right here in the middle. And the last one that I could test is anything past 3.2, which I could put like 4. So I could come up here, I could copy this, press 4, whoops, or 34, and I'm going to get a negative, right? I'm going to get a negative, yes.
For the test, for this this plugin, do we have to write down on the paper, or can we just say like positive?
You could say positive, yeah. Okay. But do we see how we got the positive and negative and so on and so forth? All right, if you can, please, Grant, can you go ahead and scroll down? All right, so let's finish up this part E. It says in the first 2 seconds. The first 2 seconds I have a negative and a positive. So notice my displacement's broken up when I'm traveling backwards, which is all right here. And then when I'm traveling forward, which is right here. It's the final position minus the initial absolute value, plus the final position of this minus the initial position of that. Each direction has its own final initial positions. And when I absolute value and I add them together, you should have gotten 9.296 meters. Okay? And then F, if you could scroll down, please. D and E are not the same. D is talking about the displacement between the final at 2 and the initial at 0, where E is talking about the total distance traveled accounted between all the displacements seeming as they're all positive. Yes?
I did the same equation. I put it into the calculator. I got 9.262 meters.
So here's what I'll say. Can you go scroll up? Did you put 6 decimal places, Spencer, right here?
Yeah.
And you put exactly this?
I got 1.262 also, and I took it straight from the graph.
Maybe I might have inputted it incorrectly. So this should be 6.2 is what you're saying?
Yeah.
Raise your hand if you also agree with that. Okay, my mistake, but it's still the same way. Okay, so I probably just backheated or something. Thank you. Keep going. Let's do this together. Shh. The velocity is negative, positive, negative. With me, I'm going to fill in. Not only do I need to know the zeros of the second derivative, but I also need to know the signs. So notice how I do this for this one that we're going to do together, okay? So here we go. Again, I'm doing this piece right here as far as the acceleration because I'm looking for speeding up or slowing down. All right, here we go. So menu for, oops, my bad. Let me escape. First, let's find the zeros of the second derivative. Menu 3-1. Press this key next to number 9. And I want to find from my stored function the second derivative in respect to t. So I'll put S of t. And when does it equal 0? Comma t. Control enter, 2.3 repeating. So over here on my problem, 2.3 repeating is about here. Okay? So I want to see something to the left of 2.3. I could say 1. And then something to the right, like 3. And all I care for are the signs of the second derivative. Menu 4-2. T. My value is 1. The second derivative, since we're analyzing the acceleration of my stored function S of t, it's positive. So if I do something to the right, okay, again, we could do like 3 or 4. Let's do 3. It's a negative. So just now I demonstrated how you could get those with the calculator as far as the signs go for each interval, which was positive and negative. Yes? Can I finish this real quick then?
It's kind of related.
To this right now?
Yeah.
Okay.
Can you not just look at the graph?
You can. You can look at the graph and see when is the velocity above the x-axis or below, and when is the acceleration above or below. You can look at the graph, yes.
Because that's what I did, and all I did was find the maximum point and find that.
And that's okay too.
And I got the same answer.
the graph or the numeric value, because here's the thing. I don't just want you to know how to do the graph, because sometimes, especially in multiple choice questions, they will give you values, and I know that you know the graph, but just more representative of like the signs in algebra, that's where they kind of give more of it too. You know what I'm saying? But yes, by all means, please be familiar with it graph-wise too. Okay, so just a reiteration. We know and learn calculus 4 different ways: verbally, algebraically or analytically, numerically with tables. So this is like the work. These are tables, and then G for graph. Okay, so yes, from here you could say that it is. Now look at this real quick. Some of you will do this on your tests, and I really like this work when some people do vertical lines on all the zeros, and you'll see this a lot in our next unit for sure. This is mainly why I'm trying to get you used to this notation, is for the unit that's coming as well. Okay, so this positive over here on this acceleration function, I would just say like positive, positive. This is negative, I'd say negative, negative. Ooh, that worked out. All right, and then I have the top one was positive in between. I would come over here and say like these are too many positives, and then negative, negative. So that whenever I'm looking at this, I'm stacking a positive and a negative, and then a positive and a negative. It's slowing down. Okay? And then the other place that they are stacking would be like right here, a positive and a positive, and a negative and a negative. They're speeding up. Okay? So let's say speeding up or speeds up on 1.451 to 2.333, because we'll say S prime and S double prime have the same signs. And yes, this would be union with 3.215 to infinity. Okay, and then the other one is, because it wanted to know when it was speeding up, did it say on the first 2 seconds, or it just said in general? In general? Yep. Alright, so then this one would be slowing down. I told you this is a hefty problem. Slowing down on 0 to 1.415, and this is going to be parentheses and bracket on 0, union, what? 2.333 all the way to 3.215. And the reason, because opposite signs. S prime of t, S double prime have opposite signs. Are there any questions before we start bonus pointing this up? Yes.
On A and B, where we pretty much just plug it into the calculator, we're gonna have to show much work on the test.
No. So here's what I'll say. Here's what I'll say. Whatever you type into the calculator, show that work. At least write it down, copy it real quick, what you typed into the calculator to see. You see what I'm saying? Because that still is notation that are like the free response questions on the AP exam. Okay?
Would you do that like that on the AP too?
Yep. But if it's a calculator multiple choice that you don't have to show work, yeah, just do it. Get your answer, move on. Cool. Alright.